Hi, everybody. My name is Siamet Sınır, and I work on Android Text. And today, I would like to talk about why improving your text measurement performance is important for your overall app's performance. In order to do this, I wanted to gather some numbers, and therefore I wrote a simple sample app that has a feed, and it's very similar to the applications that we use every day. It has a list of items, and each item has an image and some text into it. When we look at the text, as you can see in the picture, the username and the title for each feed item is what we call single style text. And the content contains a text that has different colors, text sizes, fonts, and etc. One important point here that I would like to emphasize: on our platform right now, the hyphenation is turned on by default. However, in this app, as you can see, there is no hyphenation applied, and the reason is Android works by some dictionaries in order to be able to hyphenate the words, and since these words are just random characters side by side, it cannot do any hyphenation. When we look at each feed item, we see that it has a very simple structure: a linear layout at top, an image view, a relative layout, and 3 text views for username, title, and content. And I'm pretty sure it's either the same or very similar to one of your apps' existing design or layout structure. What I wanted to see was, for each feed item, what is the percentage of the time spent on text versus the whole layout? Therefore, what I did is I wrote a benchmark where I called the linear layout measure on one end, and meanwhile, I recorded all the parameters that were passed to those different text views, and I simulated the same thing on those text views. Because of the relative layout here, the 2 text views at the top were getting 2 measure calls each. In order to have consistent numbers or repeatable measurements, I locked the CPU, I ahead of time compiled my benchmark app, and I set the debuggable false. And these numbers that we will see soon are for a Pixel X large that is running Android P. So the first question is, how much time does it require for linear layout to measure versus how much time it requires to measure all those 3 text views? This number was interesting. 4.16 milliseconds for the whole layout, and 98% of that time is spent on text. Since the CPU is locked, maybe normally the numbers on a real device will be lower than 4, but still the ratio will remain the same. The next thing I wondered was, if I were to disable hyphenation, how much improvement would I get from my linear layout, the full layout? And just turning the hyphenation off drops all the times by like 100%. So it improves the measurement performance by 2x. At this point, I want to remind you that hyphenation was turned on, but there was no visible hyphenation. So turning off hyphenation did not have any effect on the UI. Finally, I wanted to check how the numbers would improve if I were to use a new API that we added on Android P and also Android X, pre-computed text. These numbers were crazier. 4 milliseconds become 0.2 milliseconds. It's almost 20x improvement. I would like to describe what pre-computed text does and how it works. But before that, I would like to talk about what kind of things we went through while implementing the pre-computed text. We were asking ourselves questions like, why is text measurement so expensive? And can we make it faster? Since almost the beginning, we have been improving the text performance. But as you would understand from the number 98, it's always going to be a bottleneck. Therefore, we tried to see, can we move all this like expensive measurement to a background thread and provide an API? In terms of why it is so expensive, whenever the system calls on measure on text view, it first does some preliminary work and tries to identify the intrinsic width and height of the text that it contains. Then, according to the parameters that are passed to on measure, and also the numbers that it finds, it creates a layout. All these processes goes into our native code, because we have to use some open source libraries such as FreeType and Harpbus in order to measure our text. And when we look from the scope of on measure, 90%, actually more than 90% of our time is spent on the native code. And when we pass a string like this to our native code, what it does is it first divides it into words, and then for each word, it applies text shaping. It finds the font that it can render the character and tries to bring those characters in the word together. When we check how much time this takes compared to all the time that's spent on the native code, it is again more than 90%. So text measurement taking the 90% of the whole measurement, native code taking the 90% of the text, and shaping taking more than 90% of the native code means that most of the measurement time, at least for this app, is spent on text shaping. The system applies the same rules for all of the words, and for each word that is measured, it caches them. One of the reasons to cache them is like just after a measure or layout, there will be a draw operation, and the draw will need the same information. Then it applies line breaking and hyphenation. So one valid question here is, why does hyphenation, like turning it off, improves the performance twice? It's mainly because of whenever it tries to hyphenate, it has to apply text shaping for more words. Let's say in here, example is divided into ex and ample. It has to calculate two more, it has to do two more shaping on two more words. So the next question is, if we were to move this expensive measurement to background thread, what we would need. The first issue we encountered was before Android P, the native code was acquiring giant synchronization logs. And we fixed it on Android P. We made the logs smaller. Then we wondered, can we use the existing layout classes for such a goal? And there were two important issues at that point. One of them, layout classes need a width to be provided to them so that they can do their calculations. And that width, you would not have that width before measuring, so it was a chicken and egg problem. The other one is, the layout objects are just blueprints for the text that contain, kind of a cache on the Java side, and they do not know about the previously calculated native word layout objects. All they know is how many lines there are, where do they start and end, and what are their coordinates. So we wondered, what if we created a construct? First of all, that doesn't need the width. Second, it should be able to create it on a background thread safely. And third, it has to have strong references to those native word layout objects. This is important because in terms of layout, if you were to create a layout before you need it, then maybe when it's time to measure or render it, you will lose the word layout objects. They will be evicted from the cache, and therefore there was no guarantee that you would have the speed improvement. We wanted to extend this construct from car sequence and spannable because we wanted it to be compatible with our current APIs and also your applications. Since it is mostly interested in how the text will look, this construct needed some parameters that will change the text styling, such as the text size, color, local, and etc. One important point here is there was a reason why previously those native objects were being cached and evicted, and it is the amount of memory that they use. Right now, when you use pre-computed text, you will be spending 20 kilobytes for 500 characters. Even though it implements Spannable, which is a mutable interface, every calculation that pre-computed text does is done at the construction time. Therefore, you should not be calling set span or remove span functions with spans or styling information that will change how the text will look. Otherwise, you will get an exception, because that would invalidate all the computation and it would be useless. When we look at the parameters that pre-computed text requires, since most of the text styling information are right now encapsulated in the text paint, it requires a text paint as a mandatory constructor argument. The others are break strategy, hyphenation frequency, and text direction are the functions that you would already know from the static layout builder. Since most of the time you will be designing your text styling in your XML, either layout or styles XML, we want to add a helper function where you can create the pre-computed text parameters using a text view. However, at this point, I would like to emphasize that text view is not required to create a pre-computed text params. It is a helper function. And this function is going to make more sense when we go through how to use pre-computed text with recycler view. Since version 25, recycler view has a prefetch feature, and we want to provide ways of using pre-computed text with recycler view prefetch. And normally, on your onBind view holder, you will call set text, and then the recycler view will measure the whole layout that you just created. And we know that the measurement part of the text views are expensive. When you use recycler view with pre-computed text, you will just change set text to set text feature. And what prefetch will do is, before an item is shown on the screen, it will go to the background thread, do the text measurement, and as a result, will create the pre-computed text. When the computation is ready, it will switch back to the UI thread, and it will call set text with this pre-computed text, which will make the measurement part much faster than the previous case. Using it is pretty easy. Instead of calling set text in your onBind view holder, you just change it to be set text feature and some configuration for pre-computed text. And here, what you tell the system is, please run this task on a background thread and pre-compute my text with this car sequence, which is my data, and this display configuration. As you can see here, text matrix param compat becomes very handy to be able to create the pre-computed text params. One point here is, though, if you are changing your text styling according to the data you have to apply all the styling on your text view or spanables before calling this function. I will continue with how to turn off hyphenation in your app globally so that you can only enable it when you need it. This thing is also pretty simple, and you already saw the effect. It improves the measurement performance by 2x. What you do is, first you define a new style in your styles XML and turn off hyphenation for that style. You extend this style from a base style in order to handle pre-lollipop and after lollipop cases. And for version 21 and above, you extend this base text view style from material text view. And finally, on your theme, you set Android text view style to be your new style. If I were to summarize all the talk, I would say, first, go and turn off hyphenation in your app globally so that your measurement can be faster. And it's not only going to be the text measurement, the whole screen measurement, depending on how much text you have, will be almost twice faster. And then, please check the pre-computed text API. And if you are using pre-computed recycler view, please apply the pre-computed text and recycler view prefetch code that I showed you, so that you will get a more smooth scrolling experience for your users. This was my talk. Thank you very much for listening.